4 kilogram man standing on a scale in an elevator notes that as the elevator rises, the scale reads 827 newtons. What is the acceleration of the elevator? So we have a 64 kilogram man. So the mass, 64 kilograms. And we know that there's a force of 827 newtons acting on it. So we can draw out the free body diagram. If this dot represents the man on the elevator, or in a downward position, it's going to be mg, mass times gravity, and it's negative because it's going down. And then up will be our normal force. But notice, since the elevator is going up, this normal force is actually going to be equal to this 827 newtons. So we're trying to find acceleration, and we know that the sum of forces in the y direction is equal to the mass times the acceleration in the y direction. And so what is the sum of forces in the y direction? Well, it's n minus mg. So the sum of forces in the y direction is equal to n minus mg. So we can substitute n minus mg into this equation for the sum of forces in the y direction, and we get n minus mg equal to m a y. And we're trying to find y, so we can divide m over. We end up getting m minus mg divided by m, or the mass. That will give us our acceleration in the y direction. So now plugging in our values, we have 827 newtons minus 64 kilograms times 9.8 meters per second for gravity divided by 64 kilograms. We end up getting a value of 3.12. So essentially, this problem is telling us that if the elevator is going up, the man is going to be weighing more. He's going to feel like he's weighing more than he actually does. And we can do that by taking 827, figure that out, dividing it by gravity, which is 9.8. And equals 84, roughly. So what this means is that when the elevator is rising, he actually feels about 20 kilograms heavier because there's a new force acting on it, bringing him up. Hope this helps.